Hello everyone, welcome to my YouTube channel. In this video we are quickly going to look at the concept of quadratic equations. Alright, so what is a quadratic equation? That is where we want to begin. Okay, so a quadratic equation is defined as an equation that has the form ax squared plus bx plus c equal to 0, where a, b, and c are constants with a not being equal to 0. Okay, so and in a short while you are going to understand the reason why we have all of these definitions. So any equation that is of this form, ax squared plus bx plus c equal to 0, is referred to as a quadratic equation, where a, b, c are constants, that's ordinary numbers, but a must not be 0. And that is to say, it is quadratic equations are types of polynomials. They are a particular type of polynomials, and we are quickly going to look at polynomials so that you will know where quadratic equations are coming from. And it is because of the type of polynomials that they are, that is why you have the condition that a must not be equal to 0. Because if a becomes 0, then they will lose that particular property that makes them quadratic equation, which is that the power, the degree, the highest degree of their variable is is 2. Okay, so a quadratic equation can be in x. Of course, you can see the variable in this case is x. You can have a quadratic equation in other variables like p, like t, like s, and so on and so forth. So we'll quickly look at what is a polynomial. Okay, so if we say that quadratic equations are, examples or types of polynomials, what is then a polynomial? So we say that a polynomial is just an expression, a mathematical expression that consists of three things: variables. A polynomial is a mathematical expression that consists of a variable, some constants, and positive exponents. So it will contain exponents, but the exponent must be positive. Okay, so and these three things are going to be combined, by some mathematical operations such as addition, subtraction, multiplication, and also division. But in this case, you don't divide by variables, you only divide by constants. So you can see some examples. For instance, what we wrote here now, if you substitute a, b, and c with constants, what you have is a polynomial. So let's look at some examples of polynomials. Okay, for instance, x squared plus 5x minus 6 is a polynomial. Here you can see there is a combination of variables, and a variable here is x. And then there are constants. There's a constant here, 1, the coefficient of x squared. There's a constant here, 5, and there's a constant here, 6. And so you can have other examples. For instance, 3p raised to power 4 minus, let's say, 10p raised to power 3, maybe plus maybe 13p minus 4, something like this, is also an example of a polynomial. And you can see in this case here, there are constants here, 3, minus 10, 13, and minus 4. The variable here is p, and there are exponents here, power 4, power 3, power 1, and there is also power 0 here. Okay, so these are what we call polynomials. And now we are going to quickly look at the types of polynomials that we have which will then bring us down to what we are learning today, that is quadratic equation. And now, so talking about the types of polynomials, before we get there, now you watch that in each of these polynomials, there are different terms. Like here now, this contains about 3 terms, the x squared, the 5x, and minus 6. There are 3 terms here. And there are how many terms here? 4. 4 terms, 3p raised to power 4 minus 10p raised to power 3, 13p, and then minus 4. So there are about 4 terms. Now, in every polynomial, each of the terms are called monomials or monomial. So you call the terms monomial. Okay, so that is to say that this particular polynomial has 3 monomials, and then this one has 4 monomials. Okay, now let's look at the types of polynomials that we have. Majorly, we have groups. Okay, so there are the ones that we get depending on the number of terms they contain. Okay, depending on number of terms present in that polynomial. Okay, so and under here we have many polynomial types. Okay, so we start with the ones that have 1 term. Those ones are called monomials, just like I said now. So monomials are polynomials that have 1 term. Okay, example of this are what I just said here. Like now, x squared is a monomial, 5x is a monomial, 6 is a monomial, minus 6. All constants actually are monomials. And then there are other ones. The second type here are called binomials. Binomials are, polynomials with 2 terms. They contain 2 terms. Example, 2x plus 5 is a binomial. X raised to power 3 minus, let's say, 5x squared is a binomial, and so on and so forth. Okay, and then the third one are what we call the trinomials. You have what we call the trinomials. Okay, the trinomials are those ones that contain 3 terms. Okay, 3 terms. Okay, and example, this is a trinomial. It has 3 terms. Okay, and then you can give yourself many other examples. There abound. There are plenty of them. For instance, I can say 6x squared minus, let's say, 3x plus 5. This is a trinomial, and you can have trinomial, in any degree. You can also say, for example, x raised to power 5 minus, let's say, 3x raised to power 2 plus, let's say, x. This is also an example of a trinomial. So the only thing that qualifies them as trinomials is the number of terms they contain. So for this group of polynomials, they are classified according to the number of terms. The fourth one is called the quadrinomials. The quadrinomials, and then there are other ones like this. Now is a quadrinomial. There are 4 terms contained here. These ones contain 4 terms. Okay, so and there are many other examples of types of polynomials in this category. You can go on and on. The ones with 5 terms, the one with 6 terms, the ones with 7 terms, and so on and so forth. And then let's go to the second category. That's category B. These ones are characterized according to their degree, the degree of the polynomial. First of all, what is degree of a polynomial? The degree of a polynomial is the biggest exponent present in that polynomial, the highest exponent present in the polynomial. For example, here there are 2 variables here, a particular variable contained in 2 monomials here. So x is here, x is here. The exponent of x here is 2. The exponent of x here is 1. Now, but you can see, and there's also x here. Like I said, there is x raised to power 0 here. Now, but you can see that the highest exponent here is 2. Therefore, you would say that this is a polynomial of degree 2. You will say that the degree of this polynomial is 2. Now, if you come down to this example here, there is degree 1 here, there is degree 0 here, there is degree 3 here, there is degree 4. And in fact, there is degree 2 here also. if you don't mind, because I can say plus, something like 0p raised to power 2, and I'll still put plus here, and I have not changed anything, because 0 times anything is still 0. All right, so all the degrees are actually contained here, and so, but the highest here is the degree 4. That's exponent. The highest exponent here is 4. Therefore, this particular polynomial has degree what? Degree 4. Okay, so it's a degree 4 polynomial. So, and that is the next category we have here. Those ones categorized according to their degrees. And so we have the ones we call the zero polynomials. These ones are also called the constants. All constants are, polynomials with 0 degree. Like I said here, 6. For instance, 6 is the same thing as 6x raised to power 0, or 6p raised to power 0, or 6t raised to power 0, whatever. So there are polynomials of 0 degree. So the highest degree you can find in constants are just degree 0. And so you have the second one. These ones are called the linear polynomials. The linear polynomials are, polynomials with degree 1. Example, for instance, 2x plus 5 is a linear polynomial. All these ones are linear equations or linear expressions. So the highest degree here is 1. You can have something like 3p minus 8. This is also a linear polynomial. The highest degree here is 1. And then there are other examples you can see. The third one is now what we call the quadratic polynomials. The quadratic polynomials. Okay, so these ones called quadratic polynomials are polynomials with degree 2. That's the highest exponent you can find there is 2. And then you have other ones. You can talk of cubic polynomials, degree 3. You can talk of what we call quartic polynomials, degree 4. You can talk of what we call quintic, and many others. Many others. Okay, that's degree 5. And so these are the basic types of polynomials that we have. Now, the reason why we took time to look at this is that when you come down to our discussion of today, which is quadratic equation, you will discover that quadratic equations are, polynomials of degree 2. Polynomials of degree 2. Okay, now meanwhile, note that each of these polynomials can, appear in different types depending on this group A and group B. So what I am saying is that you can have a quadratic polynomial that is monic, that is just a monomial, and you can have a quadratic equation that is binomial. You can have a quadratic equation that is trinomial, and so forth and so on. And so now you would see that in our discussion for this class, we are going to be basically look at polynomials of this form. That's the quadratic polynomials, and so you can see that if a polynomial satisfies this condition where A, B, and C are not zeros, so you see that what you have is what we call the quadratic trinomials. Quadratic trinomials, and these are usually this is usually the major types of quadratic equations that we discuss, the quadratic trinomials. So that doesn't mean you cannot see quadratic binomials or quadratic monomials. Of course, you can see a quadratic monomial. For example, if I say x squared is equal to 0, this is a quadratic equation and it is a quadratic monomial. We can talk about say x squared plus 3x equal to 0. This one now is a quadratic binomial because it contains two terms, and of course it's a quadratic equation. And then we can also talk about the ones we are now discussing, which is the quadratic trinomials. Okay, so having seen this introduction, now the major thing whenever you have an equation is to solve that equation, to be able to have a solution for the equation you have. Okay, so we are going to be looking at solving quadratic equations. solving quadratic equations. Okay, so how do we solve quadratic equations? Okay, now to solve quadratic equations, we need majorly three methods. There are three major methods that we use, even though there is a fourth. So, but we are going to be discussing just three. And the first one is what we call the factorization method. So quickly, we are going to look at what these methods are all about, and then we will do that in a while using some examples, to really look at them. Okay, so now let's quickly look at some examples. Examples will help us, to discuss these methods and how we use them. Okay, so we begin with this first example here. Okay, so this example says solve. Okay, so we want to solve this quadratic equation using the three methods. Meanwhile, before we go on into this, remember we said that a quadratic equation is of the form ax squared bx plus c equal to 0. The a here is the coefficient of x squared. Whatever is the coefficient of x squared is your a, while the b is the coefficient of x and the c is the constant. Okay, so the constant, this one doesn't usually have x, or it has x to the power of 0. Okay, so now for instance, in this case, now our a here is 1, our b here is minus 4, and our c is minus 21. Okay, so please, it's important we note that. All right, so now let's quickly go on to what we have. So how do we solve this solution? Okay, so we want to see how to solve this using the three methods. So I'm going to begin with factorization method. Okay, so by factorization, what are we expected to do? You have x squared minus 4x minus 21. So all you need to do here in factorization, there are about 5 simple steps. The first step says that, this is equal to 0. The first step says that you should take the coefficient of x, which is x squared, which is a, and multiply with your c. So I'm going to take the coefficient here, which is 1, multiply with c, which is minus 21, and that will give me minus 21. So I'm keeping that somewhere. And then the second method, or the second step, says you should look for two factors of minus 21 that you will sum to give you minus 4, that you will sum to give you b. Look for the two factors of AC. Remember, this is your AC. You multiplied A with C to get this. So look for two factors of AC that you will multiply, that you will sum to get your B, the coefficient of X. And in this case, the factors of minus 21 that can do that are, minus 7 and 3. Of course, minus 7 and 3 can divide minus 21, and the sum of the two will give me minus 4. And so when you have done that, the third step says that you should use these two terms that you got here to substitute your minus 4. So we are now going to have x squared minus, if I put minus 7 here, so to substitute means just attach x to the both of them. So if I now bring it here, I am now going to have, remember that this one is positive, so I'm going to have plus 3x minus 21 equal to 0. Watch this carefully. You would see that even if I perform this operation here, that's minus 7x plus 3x, I will get back my minus 4x. So I have not changed anything. Okay, so that's the third step. And then the fourth step says that you should factorize what you have. Let us try to factorize what we have gotten. And to do that, just put two brackets, form two brackets here, and then try to bring out, the common terms in the two monomials that you have here. So, and what's common here? There is x here, there is x here. So I'll bring x out. So I'll have x. If you divide this, you have x. Then here you have only minus 7 left. Then here, what's the common term here? 3 is contained in the 2. So I'll bring it out. And so here I will have x left. and here we also have minus 7. Now you will discover that if you do this correctly, you are going to get two common brackets. The two brackets you're going to have here are going to be the same. And so when you have gotten that, the next thing now is to do that factorization. So bring out, because if I have, for example, ax plus bx, I can bring out my x because x is common here, and then I'll have a plus b left. Okay, so and that's exactly what we did here now. So and that's what we are going to now complete finally. So this is common here, this is common here, so we bring it out. So I'll bring out x minus 7, and then in a bracket I will now gather the remaining. The remaining, when I bring out this, is x, then plus 3. Okay, that is equal to 0. So, and this is the the fourth step, and the final step says that you should equate each of these brackets to 0. Why? The reason is because mathematically, if a times b is equal to 0, if you have any two things multiplying to give you 0, then it is either a is 0 or b is 0, or both of them are zeros. And so it is that condition that we are going to use. So now, since this is let me remove this. Okay, so since the product here is equal to 0, the implication is that it is either x minus 7 is 0 or x plus 3 is 0. Okay, so, and if that then happens, I can easily now find my x by making x the subject here. So my x is equal to 7 or minus 3. And that is the solution for this quadratic equation using factorization method. And so can we do this same question using the completing square method? Now remember the 5 basic steps here. First one is multiply a and c. When you have done that, second one is look for two terms, two factors of ac that will sum up to give you b. And so when you do that, you will use it to substitute your bx, remove bx and use the two terms you have gotten to substitute. And then the next step is to factorize. When you factorize, then you get two brackets. Then the final step is equate each of the brackets to 0 and then solve for x, and you will have your answer. And that is the required solution. Okay, so quickly, let's go to the next one, which is the method of completing square. Okay, so here we bring down our equation as usual. Here we have x squared minus 4x minus 21 equal to 0. What do you do? The first step here, there are about also 5 or 6 steps to take. The first step here says that I should take the constant. If you have any constant, take it to the right hand side. Remember, this is the left hand side, and where you have 0 is the right hand side. So we want to take the constant, which is minus 21, to the right hand side. And when you do that, you will have x squared minus 4x is equal to, when minus 21 crosses, it will become 21. And the next step says, make the coefficient of x squared to be 1. And how do you do that? Divide through by its coefficient. Now in this case, the coefficient of x squared is already 1, so I don't need to do this second step here. But we are going to do an example where the coefficient is not going to be 1. So in that kind of example, you would need to divide every term here by that coefficient so that the coefficient here will become 1. So we jump this step. Now the next step says that we should add to both sides the square of the half of b. Now in this case, what is our b? Our b is minus 4. And so they said, the step says we should add to these two sides the square of the half of this. Now what is the half of this? The half of this is going to be minus 2. And so we are now going to square it and then add it to both sides. Okay, so that means the next step we are going to have is going to be x squared minus 4x. Then I'm going to add to this side minus 2 all squared, and then I'll also go to this other side and I will have my 21 is here already. Let me remove this. My 21 is here already, and I am adding minus 2 all squared. Okay, so that having been done, we go to the next step. The next step says gather the squares on the left hand side. Please, it is very important that you don't simplify this, that don't open the bracket. You can open the bracket here on the right hand side, but on the left hand side, always leave it as the square. Okay, here now, so that is because of the next step that we are going to take. That step says we should gather the squares on the left hand side. Okay, so to do that, we are going to have x, and then here you are now going to have minus 2 all squared. Okay, and then you would see that if you open up this bracket, you still get back this. That's actually what we call the completing square. This is actually the completing square that we have done here. Okay, so this is the square of this. Okay, so if you open this bracket, you get back the whole of this on the left hand side. So but we just say gather the squares, and when you have done that, go to the right hand side and simplify what you have, which is 21 plus the square of this is 4, and that will give us 25. Okay, and then the next step says take the square root of both sides. So if I take the square root of both sides, what is going to happen? This square is going to go. So and then I'm going to have x minus 2 is equal to the square root of 25. Now, but always note that whenever you take the square root, that you are going to have two values, that's positive and negative. And so what we have now is x is equal to the minus 2. So the final step is now to solve this to get your x. That's make x the subject of the formula. So I will take this to the other side, and it will become 2 plus or minus the square root of 25 is 5. Therefore, my x is equal to 2 plus 5 or 2 minus 5. Remember, there are two signs here, and that's going to give us 7 or minus 3, which is exactly what we got in the, using the using the factorization method. So it's just a combination of simple steps, about 6 or thereabout. Remember, the first step says take the constant to the other side. Now make the coefficient of x squared to be unity, that's to be 1. That means divide through by the coefficient if it is not 1. The third one says that we should add to both sides the square of the half of b. That means divide b by 2 and add that, the square of it, to both sides. And then after that, the next step says that you should gather the squares on the left hand side. After that, it says take the square root of both sides to remove this square, and then solve for x by transferring whatever you have here to the right hand side, and then simplifying. Okay, and that is just it. And then finally, we are going to look at the third method here, which is the quadratic formula. Okay, so the quadratic formula, we are still going to solve this same example. The reason why I'm using this example is so that you will see that the three methods are just the same. They will give you the same answer. So if you are given any quadratic equation to solve at any time, it is your choice. Choose any method, except the examiner tells you what method to use. But if not, you are allowed to use any method, because all the methods will give you the same solution. Okay, so quickly, let's try to solve this using the formula method. Now, the formula method is, now, for me, looks like the simplest method. It has to do with a formula, and that formula is generated using this second method. Maybe in one of the sometime later, I'm going to do a video on how to derive the formula method using the completing square method. Okay, so how to derive the formula here, sorry. And what is the formula? The formula says that the x we are looking for is equal to minus b, negative b, plus or minus the square root of b squared minus 4ac all over 2a. Remember what your a, your b, and c. r in an equation. The a is a coefficient of x squared, your b is a coefficient of x, and your c is a constant. And so in this example now, our a is simply equal to 1, our b is equal to -4, and our c is equal to -21. All right, so we'll now quickly try to substitute. So that means that our x is going to be equal to minus b, and remember b is -4, so you put -4 here, plus or minus the square root of b squared, which is -4 squared, minus 4 times our a is 1, 1 times -21, right? And that is all over 2 times -1. Okay, sorry, 2 times 1, not -1. Okay, so our a is 1, not -1. Okay, so now we try to simplify what we have here to generate our answer. And that's going to give us minus here is 4. And then we have plus or minus. And this is the square root of, square of this is 16. Then let's try to, multiply this. This is -21 times -4. And that will give us plus 84 plus 84 all over 2. Okay, so we are going to have here to be equal to 4 plus or minus. This will give us the square root of 16 plus 84 is going to be equal to 100. So we'll have the square root of 100 all over 2. And that is simply equal to 4, the square root of 100 is 10 all over 2, and that is going to give us, so here we are going to have 4 plus 10 over 2, or 4 minus 10 over 2. So you see, in all of the cases, you always get 2 answers for your x. Therefore, our x is equal to 4 plus 10 is 14 over 2 is 7, or 4 minus 10 is -6 over 2 is -3. And so you see, once again, we have gotten the same answer as what we have in the 2 other methods. And that's how to solve quadratic equations using any of these 3 methods. Okay, using any of these 3 methods. And that's where we're going to end this video. But before we go, I would like to give us an example to look at. Let me write it here. Exercise. Okay, so 3x squared minus 4x minus 15 equal to 0. Use the 3 methods to try it and see what you have. You can see in this case there is a coefficient that is not 1, so that means that second step will hold. Okay, all right, and that's all we have for this class. I'm Precious Ugweze. Kindly subscribe to our YouTube channel, share, like our videos, to your friends and loved ones, and make comments. You can reach out to us. I usually add my email and other social media handles on our description. You can check it out. Reach out to us for anything. Have a nice day. See you in our next class. Bye.